Okay, we're going to continue our discussion of the dot product, and this time we're going to be looking at projections. So let's start with two vectors. We'll say this is vector B, and this is vector A. All right, now we can see that if we wanted to project B down onto A, we would get a new vector that lives on A, this one right here. So if I project my vector B onto A, I get this new vector, which we will call the projection of B onto A. And for the ease of this demonstration, I'm going to actually call this vector right now X. Okay? And we see that there's an angle between X and B, and we'll call it theta. Now, notice that the magnitude of X over the magnitude of B is precisely the cosine of theta. Right? As we can see on our triangle right here. Also, we notice that since X lies on A, that X is just some scalar multiple of A. The way I've drawn it right now, it looks as if it's smaller than A, but it could actually be longer than A, and we'll draw some pictures to demonstrate that here in a minute. But we do notice that X is some scalar multiple of A, which means the magnitude of X is equal to C times the magnitude of A. Okay? Now, what else have we learned? We learned that the magnitude of X is equal to the magnitude of B times the cosine of theta. I'm just working from this equation up here, right? And so what we learned on the second equation, that means that C times the magnitude of A is equal to the magnitude of B times the cosine of theta. Okay? And our goal right now is to solve for C. But before I do that, I'm going to multiply both sides, and you'll see why in a minute, by the magnitude of A again. So I should have the magnitude of A squared is equal to the magnitude of A times the magnitude of B times cosine of the angle between them. Which means C, my scale factor of A, is equal to the magnitude of A times the magnitude of B times cosine of theta, all divided by the magnitude of A squared. And if you recognize this from the last video, the top is just the dot product of A with B, and then the bottom is the magnitude of A squared. So my scale factor is the dot product of A and B divided by the magnitude of A squared. And that means, moving to a new board, that the projection of B onto A, which we called X, which we recognized was equal to a scalar factor of C times A, and we discovered that C was equal to the dot product of A with B divided by the magnitude of A squared times that vector A. Okay, so this is the projection of B onto A. We can find it by that formula, and that is, by the way, a vector. All right? Perfect. Okay, well, what's the magnitude of this vector right here? Well, the magnitude of the projection of B onto A is equal to the magnitude of A dot B over the magnitude of A squared times, so this is my scalar right here, times my vector A. So what it's really equal to is A dotted with B over the magnitude of A squared times the magnitude of A, which reduces to A dot B over the magnitude of A. And what we call this right here, the magnitude of the projection of B onto A, is the component of B onto A. A dot B divided by the magnitude of A. Okay, so This is the vector that's created by projecting B onto A, and this is the length of that vector. And what does that tell us about the dot product in some kind of geometric interpretation? That tells us that the dot product itself is equal to the length of that vector, sorry, that should be a P, the length of the vector of B projected onto A times the magnitude of A. Very cool.